Hello friends, today we will discuss about the status of air quality monitoring in India. Basically we will look into how air quality monitoring is carried out, what is its importance, what is its significance, what are the thumb rules or the processes which determines the locations, number of air quality monitoring stations, frequency, all those kind of things we will discuss. So, before going in detail, I can give you this contents list for this lecture. Like we will look into very basic, very brief information of air quality monitoring, then different kind of types of monitoring, what are those types of monitoring or the way we carry out the monitoring, air quality monitoring in different ways. So, we will discuss about them. Then stationary source emission monitoring we will look into, because air quality monitoring and emission monitoring, two different things are there, but they are both important. Then we will look into ambient air monitoring. So, different kind of pollutants which we focus on when we go for air quality monitoring, ambient air quality monitoring. Then the number and distribution of monitoring locations, selection of monitoring locations, those kind of principles, basic rules, and the timeline of air quality related regulations which have been implemented over the period of time in India. So, that we will look into. Then National Air Quality Monitoring Program we will discuss briefly, and the non attainment cities that is exceeding air quality standards. So, about those cities we will discuss. Then we will focus on National Clean Air Program, which is very important program which has been sponsored by central government of India, National Clean Air Program or NCAP, and after that we will conclude. So, when we talk about basics or brief information on air quality monitoring, so you can say that monitoring is nothing but a general term which relates to like collection of data or measurement of the data and the informations assessing, processing after the collection of the those air quality related data, right. And the monitoring is an exercise of measurements of different levels of air pollutants basically, and it gives us some information which is related to like how much is the level of the air pollution of a particular pollutant at a given location, where this pollution is there, and what is the time series or when this pollution has occurred. Those kind of things are determined with the help of air quality monitoring. When we look into like spatial differences or temporal differences or trends, so with respect to the space or place, you can see the variation may be there from state to state, within the state, city to city, within the city, from location to location, there may be differences in the levels of air pollutants. Similarly, over the period of time, like if we monitor from one year to another, so there is variation in different months. So, average concentration, air quality concentration in different months may be different because of several factors, like emissions may be different, plus meteorological factors which also kind of govern the pollution levels, because sometimes wind is more, then it can take away the pollutants, and then when precipitation is there, then again cleansing of this air becomes very easy. So, those kind of meteorological parameters also influence the air quality. So, the temporal variation is there, spatial variation is there. When we look into the objectives or aims and like motto of the air pollution monitoring or air quality monitoring, then what is the purpose it serves basically. There are numerous purposes basically. You can like it can provide a very sound and scientific basis for development of cost effective control policies and programs or technological interventions which are needed to control the pollution discharges or emissions, and to improve the air quality, you can say. And it also helps in evaluation of like potential impacts of air pollution on population health and environmental health or welfare of the public, because the air quality determines the public health related issues also. Then it also provides information about like reliable information and up to date information on air pollution levels related to particular location or related to particular source. So, that way we can control that particular source which is emitting more of the air pollutants. Then it also helps in assessing the air quality standards, whether those air quality standards are being met or not. If it is exceeding at a particular place, then what are the responsible factors for that? Is it because of some topographical factors or because of some source emissions, right? Then it also help us in determining the impact of air pollution on the ecosystem and our natural environment, and also assessing different policy measures which we have taken, okay, to improve the air quality. So, how much impact is there of that policy or technological intervention. So, that way air quality monitoring gives us a lot of information from that perspective. Well, area for monitoring is determined on the basis of like emission sources, whether it is domestic or industrial, transportation or agriculture related, natural, and then those pollutants which are being emitted, what are the nature of those pollutants, then the location and magnitude of the pollution intensity, all those things govern the where we need to monitor, right. Then meteorological factors also important, because some areas are prone to like temperature inversion which can enhance the pollution levels, right. So, those kind of things. Then topographical issues, undulation is there or flat terrain is there, geographical issues, population centers where lot of population is there, so receptor may be more. So, it may be needed to monitor air quality, because they will be impacted, their health will be impacted if lot of large number of population is there. Then historical monuments are also important, because they can be affected by the air quality. So, we need to monitor the air quality in and around those places. Then also like some are very sensitive zones like natural parks, forests and wetlands. So, pollutants can really change their particular ecosystem. So, we need to know how much pollution is there in and around those particular areas, right. Next is like if some areas are vulnerable to pollution plumes, then again it is needed to monitor, so that we can learn which particular pollutant is the problematic, right. Then the plan for the development, like if we are planning some particular industrial cluster or some new city, something like that, then also we need to know the background concentration, so that we can foresee that after implementation of or execution of this plan, what will be the air quality at that location. Okay. Then if there is complaint from the public or some person that at a particular place some pollutant concentration is increasing because of some source or because of some industry, and the industry is not taking care of that, then again air quality monitoring is required to see whether it is true or not, right. And then any epidemiological studies on air quality affect the health already carried out. So, relationship between the epidemiological studies or the public health or the health on particular group of the public like children or old people, and its relationship with the pollutant. So, those kind of relationships can also be established by virtue of this data which is obtained from air quality monitoring. When we talk about what kind of monitoring techniques are there, then you can see like stationary source emission in monitoring can be there, when some stack is there and you can monitor the emissions which is coming out of that stack. Okay. On road mobile van related monitoring instruments can be in that mobile, and you can travel and you can also monitor the air. So, you can have a kind of trajectory of the air quality from one place to another. So, that kind of profile you can generate, a spatial profile, temporal profile. Then ambient air quality can also be monitored by virtue of manual instruments or automatic instruments, right. Then remote sensing related instruments are also available nowadays, or satellite observations can also be done. So, you can have this column of the air, you can see how much pollution is there of a particular pollutant, whether particulate matter or ozone or those kind of pollutants you can easily monitor from the satellite also. There are certain sensors and they can give the reading of those concentration in that column. Then when we talk about like ambient air quality monitoring, so we have to see like what is the purpose of that, because in ambient air different pollutants are there. So, we have to monitor different pollutants. So, accordingly we need to install the instruments, and we can assess the concentration of criteria pollutants, for example CO or nitrogen dioxide or oxides of nitrogen like NO, NO2, NO3, those kind of things, right. Then ozone or heavy metals, etc., VOCs, all kind of these pollutants can be monitored by some technique, some instruments, special instruments. Okay. Then stationary source emission monitoring is done when stack emissions are there. We want to know how much emission is going out of that stack, and what is the concentration in the exhaust gases, which will be diluted afterwards in the air. So, those kind of things, because we need to know the performance of this air pollution control equipments. For example, you want to see some ESPs there, electrostatic precipitator at a, let us say like coal based thermal power plant, etc. So, you need to know how much performance intensity is there, or what is the efficiency of that instrument. So, unless you know how much is the input and how much is the output. So, those kind of stationary in the stack emissions you can see and know about those emissions. Then you can see like on road mobile monitoring, which can be done, as I said, you can have different kind of instruments in the mobile van, and then you suck the air through those inlet pipes, and there are sensor based instrument also, they can give the readings of those pollutants, and you can see the profile of the pollutants with respect to the time and the space. Well, when we talk about remote sensing, satellite based monitoring, then also depending upon the pollutants and depending upon the location, whether city you want to focus, you want to focus the whole the state. So, accordingly you can have this air quality monitoring and readings can be taken. Well, when we talk about stationary source emission monitoring, so as I said there are different components of that particular process, like indicators of the performance, then measurement techniques, different measurement techniques, monitoring frequency, averaging time, all these things are important when we carry out the emission inventory, emission monitoring of the stationary sources. So, like when we talk about indicators performance, so like proper operation, this is done for demonstrating the proper operation of the air pollution control measures which have been implemented. Then compliance of the applicable emission limitations or standards, because when we will have some reading, only then we will be able to compare what are the norms and how much emissions are coming out. So, that indicator performance is done by this stationary source emission monitoring. Then there are different techniques like continuous emission monitoring system can be there, CEMS, okay. Continuous opacity monitoring system can be there, continuous parametric monitoring system can be there, or manual inspections that include records and processes, different conditions, work practices, all those things can be combined, and then you can evaluate those things to see what is the emission, basically what is the intensity of the emission and what is the air quality impact of that emission in that surrounding. Then the frequency means like hourly or weekly, depending upon the purpose you can decide the frequency basically, okay. And then even if you are having like hourly, then you can convert it into weekly or monthly, depending upon what kind of purpose is there for this monitoring. Well, averaging time again you can do, because instruments are there which can give you per minute data, per second data, per hour. So, then you can process what is the averaging time depending upon like you want to compare with the 24 hourly emissions or hourly emissions. So, accordingly you have to do the averaging time. So, that comparison can be of the same unit. When we talk about ambient air monitoring, then again it can be done like through manual monitoring by hand instruments, okay, and then automatic monitoring. So, manual monitoring is basically like some instruments are there, and you do like physical activity when, for example, you are monitoring particulate matter. So, you have to weigh the filter paper, you have to install it, then you have to run, you have to check the reading. So, that means a lot of involvement is there of the expert or the skilled person who knows how to carry out the air quality monitoring using that particular instrument. Okay. So, there are well established guidelines which needed to be followed, and the manpower must be skilled, and the manual data generation and dissemination is possible by this particular methodology. So, there are several instruments which are used for manual monitoring, like improved West and this Geek method, modified Jacob and Hosier method, then chemical method can be there, gravimetric method can be there for particulate matter. So, these are the listed different kind of instruments which can be used. So, if we go one by one, then this particular method which is known as improved West and Geek method, this is used for monitoring the sulfur dioxide. And there are these annual standards, okay, 50 and 20 for industrial, residential and ecologically sensitive areas. Then 24 hours these guidelines or concentrations are also there, which are 80 microgram per cubic meter. So, accordingly monitor data can be compared with these guideline concentrations. Similarly, if we talk about modified Jacob and Hosier method, then this is done for measurements of NO2, nitrogen dioxide, okay, and we can compare with, again this table gives the air quality standard, national ambient air quality standards for 24 hours and for annual standards. So, whatever data you are processing, you can compare accordingly. When we talk about ozone monitoring or sampling, then this chemical method, which is also known as buffered potassium iodide method, this is used. Okay. We will look into these methods in detail later on. I am just giving you brief introduction about different instruments or methods which are used for air quality monitoring. Like for ammonia, and we need to use this indophenol blue method. Okay. For gravimetric method, like for PM10, particulate matter of 10 micrometer size or less than that, RSPM it is also known as, like respirably the suspended particulate matter. So, the same gravimetric method can be used for PM 2.5 also, and you can see these ambient air quality standards which need to be met. Well, like gas chromatography method is there, adsorption, desorption followed by gas chromatography, which can be used for benzene measurements or sampling. And if you want to monitor this benzopyrene, then solvent extraction followed by HPLC. HPLC is high performance liquid chromatography. So, and gas chromatography can also be used. So, these methods are necessary for measurement of benzopyrene. Similarly, if you go for heavy metals like lead or nickel, then you need to go for atomic absorption spectrometer, AAS. There are different makes, different companies make it, but this is the methodology which is used for this particular these particular pollutants. If you go for arsenic sampling and monitoring, then atomic absorption spectrometer AAS is there, and using EPM 2000 method can be used for this arsenic monitoring. When we go for automatic monitoring, then there are sophisticated analyzers which are sensor based, and different techniques are there, and the quality assurance, quality check is to be done, air quality index development, all these things can be done by automatic monitor, because in this case intervention of human is very less. Automatically measurements happen, sensor based calculations happen. So, computer based calculations are also there. It can help us calculating air quality index or early warning systems, forecasting, modeling, all those things are basically done by these automatic monitoring systems, because they give the real time observations, real time measurements, okay. And different methods of the ambient air monitoring of the automatic nature. So, we go for like ultraviolet this fluorescence method, or this photometric method is also there. So, these are listed, you can see like ultraviolet fluorescence method is for sulfur dioxide. Then for oxides of nitrogen or ammonia, you can use this chemoluminescence method, and ultraviolet photometric method can be used for ozone. Similarly, other methods are also there for carbon monoxide and PM 2.5, PM10, all those different pollutants can be measured by these automatic sensor based equipments. And gas chromatography is quite expensive, but this can help in measurements of benzene and there are some sensors also which are used for measurements in automatic fashion. Well, so when we go for like selection of pollutants, which pollutants are important. So, this depends upon like what kind of health impacts we are going to assess or evaluate. So, accordingly we need to go for that particular pollutant. Also it depends on what kind of major pollutant sources can be there. So, accordingly you can choose the pollutants, like if you want to measure near highways or vehicular air pollutions, then basically carbon monoxide or nitrogen dioxide, benzene, fine particulate matters like PM 2.5, they are the important because they are emitted in large quantity from these particular sources. When you go for like coal based power plant, then SO2, particulate matter are more important. Okay. Urban areas you can go carbon monoxide, SO2, NO2, PM 2.5, PM 10. So, depending upon nature of the pollution sources and other issues, you can choose which particular pollutant we need to monitor. Then we come to how many number and distribution of monitoring locations can be there. Okay, how many samples sampling stations we should install. So, that depends on various factors, okay, like size of the area, how many people are living in that particular area, okay, frequency of the data which we need. So, all those factors influence the number of these locations or sampling stations. For example, if you go for like SPM monitoring, and this is the population data. So, it gives the number of these monitoring stations which are required. So, up to 1 lakh population, 100,000 population, minimum 4 stations are recommended. Then when population increases, so there is some relationship, empirical relationship which can be used to decide to determine the number of stations. So, similarly for all different pollutants we can get the number of these stations, air quality monitoring stations. Like carbon monoxide, you can have only one station is enough for 100,000 people, whereas for SPM you need 4, for NO2 you need 4, for SO2 you need 3. So, depending upon pollutants, number of stations also vary. Then there are like on the basis of the experience and expert opinion and statistical parameters, like 3 monitoring stations are chosen as one in each residential or commercial, sensitive and industrial areas. So, that can give fair level of air pollution in different nature of the areas. Okay. And the distribution of monitoring stations can also depend upon pollution sources and population. So, if in a particular location more population is there, then you can add additional these instruments, right, depending upon the sources also. Okay. Then if we go for like selection of monitoring location, so that location how to decide, basically that location should be representative, means if you are having so many sources in an industrial location, so you choose that location which can be representative of that industrial area. Okay. And if you want to have the background concentration, then you should be locating that sampling station quite far away from those major sources. Okay. So, that way the representative site, this concept must be kept in mind when we are choosing the monitoring station. Then there are other rules and regulations also, like it should be at least 25 meter away from the domestic chimneys, those kind of thing, guidelines are there. Okay. It should be like 1 meter clearance from the those absorbing surfaces like buildings, walls, etc. So, all these things need to be kept in practice. Then those locations must also follow like the law of comparability. So, all 4 sides should be quite open, otherwise not only it will not be representative, it will not be comparable with that particular site or location. Okay. Then it should be away from the balcony and this traffic pollution, like if you want to have, then also it should be away like 3 meter above the street level. Okay. And it should be 200 meter from the unpaved roads, because then resuspension of dust etc. can influence the readings. It will give quite biased reading. So, we have to avoid those biased reading, disproportionate reading. Then like for longer period or easy access, all those power supply, all those things are factors which can influence the location. If there is no power, then it is very difficult. If you are having like diesel generator, then it can also add to the pollution. So, those kind of things we need to keep in mind, that this location should not be disturbed by some external sources. Topography and meteorological factors also influence, like if it is a mountainous region or valley, then how to keep this, okay? Land, sea, breeze, all those things should not again influence this monitoring exercise. Well, when we look into like different regulations which emerged or which were framed by the different government agencies, especially like CPCB, MOEF, Ministry of Environment and Forest and Climate Change. So, you can see like in 1974, from Indian context we are talking about. So, air quality regulations which emerged in India. So, timeline can be seen like in 1974 the Central Pollution Control Board was established. Okay. In 1981, then it was entrusted, the CPCB was entrusted with the powers and functions under the Air Prevention and Control of the Pollution Act. In 1986, this added like provisions of Environment Protection Act. So, evolution has happened over the years. In April 1994, National Ambient Air Quality Standards were introduced, NAQS, and then in 1998 January, this Environment Pollution Authority EPCA, Prevention and Control, this was established to address air pollution related issues in NCR, National Capital Region of Delhi. So, especially because this was affected by several regional sources, etc. Then again in 1998 National Ambient Air Quality Standards were revised, right. In 2009 these PM 2.5 were added, these air quality standards. In 2014 again this National Air Quality Index methodology was established. So, how to calculate the AQI. Okay. In 2016 PM 2.5 okay, included for all the manual stations under the this National Air Quality Monitoring Program. Otherwise, in 2009 it was added in the air quality standards, but the monitoring was not happening across the country, but later on it was added in air quality monitoring stations also. Then in 2016 December, this graded response action plan GRAP established to address air pollution emergencies in NCR Delhi. Okay. And then in 2018 this National Clean Air Program NCAP, this draft of this particular program, which is very ambitious program, was released with 637 crores of the budget, and the 102 non-attainment cities were identified. Later on 20 more additional cities were added into it. Okay. In 2018 October, this NGT, National Green Tribunal, directed the states and union territories with non-attainment cities under NCAP to prepare action plan, how to improve the air quality, how to reduce the air pollution in those particular cities which are non-attainment in that particular criteria or framework. So, then in 2019 this NCAP, a time bound national level strategy to tackle the increasing air pollution in those cities with the help of this MOEFC, Ministry of Environment and Forest and Climate Change. Okay. So, that really launched this ambitious program, and there was this central committee to monitor was also constituted. In 2020 the implementation of Bharat Stage 6 norms were done, because we were having this Bharat Stage 4 like Euro 4, okay, similar to Euro 4. So, rather than Euro 5 we went direct to Euro 6. So, that is known as Bharat Stage 6, right. Then in 2024 we will see, because this NCAP is having the target, okay, to reduce the PM 2.5 concentrations in the ambient air in non-attainment cities by 20 to 30% with respect to 2017 levels, okay, 2017 levels. So, that is the target in 2024 we will see. So, those kind of activities are going on in that way. Well, National Ambient Air Quality Monitoring Program is pan India program, and it was launched in stages manner, like large cities, then in rural areas also. Now 344 cities are having 804 operating stations for this particular program. This is very large program, and it gives air quality profile for all the cities and countryside you can have for different pollutants, criteria pollutants particularly. So, these are the parameters which are monitored under this program, and the frequency is like 4 hourly sampling for gaseous pollutants and 8 hourly sampling for particulate matter with a frequency of twice a week, and 104 observations in a year, that is minimum to as per these standards NAQS. Okay. And monitoring agencies are Central Pollution Control Board, then there are state pollution control boards, then pollution control committees in different cities, local bodies, National Environmental Engineering Research Institute NEERI, all these integrated manner monitoring happens, and all the data is collected and analyzed. So, you can see the development or increasing in the number of monitoring stations from 1984, when only 7 stations were there, and now it is 804 stations. So, that way means we are expanding in number of stations. So, that give better profile, spatial distribution of the air pollution, and all those things are better nowadays, and it is still increasing. Basically, different agencies are coming for installing their stations also in addition to these government agencies. Well, different states have different number of air quality monitoring stations. So, the highest number are in like West Bengal, Maharashtra, Uttar Pradesh and Andhra Pradesh. Okay, they are having large number of air quality monitoring stations. So, they can have better profile of the air quality across their regions or different cities. So, this is again given like in May 20, this was only 230 continuous monitoring stations, now it is 312. So, continuous monitoring stations are also increasing in number, and that really helps in forecasting of the air quality for near future forecasting or comparison of air quality indices. All those things are possible because of these continuous monitoring stations. Well, again you can see this number is continuous monitoring stations from September 15 when it was 30, now in November 21 it is 312, and continuously they are growing in number. Okay. So, again their number is also varying according to states. So, the pioneer states are like Delhi, Maharashtra and Uttar Pradesh in having large number of continuous monitoring stations. Non-attainment cities, those cities which are exceeding the air quality standards. Okay. So, those are the non-attainment cities, and as I said it was 102 initially, then more added, now 122, and then some million plus cities were also added, and it is now 132 basically. Okay. So, you can see the number of non-attainment cities in different states. So, highest number are in Andhra Pradesh, Maharashtra and Uttar Pradesh basically. So, they are the focused areas. You can see the distribution of these cities across this country, and they are having different levels of air pollutants, they are also shown in this. So, the NCAP program, National Clean Air Program, this is very ambitious program, and this will really be a game changer kind of thing. This will improve air quality in a big way, because very focused and targeted efforts are being made in an integrated manner, where central government, state government, local bodies all are involved, and educational institutes, they are also involved. So, experts and everyone means those stakeholders, their participation, all these approaches are there, well documented. So, uniformity is there, it is not like ad hocism, very systematic, in a systematic way this program is implemented. So, I am sure that this will help in improving the air quality of different cities which are right now non-attainment cities, but they will be cleaner in near future. And you can see the key components for this particular program are like health and economic impact studies and source apportionment studies, all those kind of studies are also incorporated. And the broad strategies, you can see the local government, as I said, city level, different departments are involved. So, their integrated approach or integrated efforts will bring light to the problem. Well, in conclusion, we can say that the air quality monitoring is one of the important steps in combating air pollution, and continuous air pollution monitoring is more reliable and faster than the manual monitoring, if provided calibration is proper. Because if you are just using the instruments without calibration, then reliable information may not be there. Okay. And National Air Quality Monitoring Program is one of the first step by Indian government which was taken up and towards tackling the air pollution problem. And NCAP program, as I said, is more focused and target based program which will tackle this air pollution situation in India, and air quality will be improved in a significant way. So, this is all for today. You can go through these references for additional information. Thank you for your kind attention. See you in the next lecture. Thanks again.